Every time you meet a new function, you want to shake its hand and say, hey, what's your domain? And to get it, let me show you two pictures here, actually. So remember earlier we graphed f of x equals 2 to the x, and it looks something like this. Remember that? It turns out as long as the base a is bigger than 1, any graph of any exponential function of the form f of x equals a to the x will look kind of like that. It might be steeper if a is bigger than 2, or if a is between 1 and 2, it won't be as steep. But this would be generally what the graph looks like if this would be the graph of f of x equals a to the x when a is bigger than 1. So it looks more or less like the graph of f of x equals 2 to the x, depending on the value of a. But there's another picture. If a is between 0 and 1, that's the other possibility, then it actually goes downhill from left to right. It'll look like this. Both graphs will go through 0, 1, by the way, because when you plug 0 into the exponent, you still get 1 as an output. So this would be the graph of f of x equals a to the x if a is between 0 and 1. Remember, we don't let it go negative. So those are the two possibilities. If you don't believe me, just try graphing 0.5 to the x power. You'll get a graph that looks more or less like this. It goes downhill. Either way you look at it, though, the domain remains the same. Okay, domain inputs, so look left to right. Does the graph ever actually stop here? It keeps going forever. It gets closer and closer as it goes to the left to the x-axis, and it doesn't go down that quick necessarily, but it keeps going forever. And it keeps going up, but it keeps getting wider that way too. So what's the domain going to be? And by the way, both graphs have that feature, but except one goes uphill from left to right. One is increasing from left to right. One is decreasing. But both have that feature where they're defined for all x values. So what's the domain? Okay, so the interval, going back to interval notation, I like to switch it up between inequality and interval notation and set builder notation so you remember them. So going back to interval notation, the domain, negative infinity to infinity, that means all reals. What about the range? Either way, either graph you look at, the range is the same as well. How low does it get? Almost. How high does it get? How low does this guy get over here and then this guy? Does it ever get to 0? Almost though, right? So it gets as close as you want to 0 because y equals 0, the x-axis is the horizontal asymptote. So I would say, okay, think low to high. The low value is 0, but not including 0, right? As close as you want to 0, but not including 0, so parenthesis around that. What's the high value? How high do both of these get? They keep going, right? So 0 to infinity. Domain and range.